Pluto had it coming from the beginning. Pluto's orbit crosses that of another planet. Pluto, the enigmatic small planet at the outer reaches of our solar system, is stirring up excitement in the world of astronomy. Recent reports hint at a possible encounter with Neptune, raising concerns among scientists and space fans. Notable figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the implications of this cosmic event. But how did Pluto end up on a collision course with its neighboring planet, and what could the celestial clash mean for life on Earth? Join us as we unravel how something massive just collided with Neptune and how scientists have been left worried by this cosmic anomaly. Pluto, once hailed as a full-fledged planet, underwent a transformation in its status, being reclassified as a dwarf planet due to its peculiar orbit. Despite this demotion, Pluto still captivates and intrigues the astronomical community. Recent predictions from esteemed scientists like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's trajectory potentially intersecting with Neptune's, hinting at a looming threat of collision between the two celestial bodies, which could have significant repercussions for Earth. Pluto's journey around the Sun stands out due to its unique characteristics within our solar system. Its orbit is exceptionally lengthy, spanning a staggering 248 years. Since its discovery in 1930, Pluto has yet to complete a full revolution around the Sun. Adding to its mystique is the highly elongated shape of its orbit, a departure from the more circular paths followed by the major planets. Furthermore, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a steeper incline compared to other planets. The combination of Pluto's inclination and its elliptical orbit introduces layers of complexity to its orbital pattern. One notable aspect is its periodic intersection with Neptune's orbit. For around 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, defying expectations based on their respective positions in the solar system. Delving deeper into Pluto's orbit, it's fascinating to note that it's not a perfect circle but rather an elongated ellipse resembling more of an oval shape. This unique orbit results in significant variations in Pluto's distance from the Sun throughout its journey. At its closest approach, Pluto comes within about 30 astronomical units, AU, of the Sun, while at its farthest point, it reaches over 49 Australian dollars away, almost twice the distance of Neptune from the Sun. Moreover, Pluto's orbit is inclined at an angle relative to the orbits of the major planets in our solar system. This inclination not only contributes to the complexity of its orbit but also plays a crucial role in its interactions with other celestial bodies, particularly Neptune. When Pluto crosses paths with Neptune, their gravitational tugs influence each other, altering their trajectories over time. The intricate dance between Pluto and Neptune underscores the dynamic nature of our solar system. While Pluto was once considered a lone wanderer in the outer reaches, its close encounters with Neptune highlight the interconnectedness of celestial bodies, each exerting gravitational forces that shape the paths of others. In recent years, advancements in observational technology have allowed astronomers to track Pluto's movements with greater precision. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely discounted, prompting continued monitoring and study by the astronomical community. Despite its diminutive size and distant location, Pluto continues to command attention and curiosity among scientists and enthusiasts alike. The question arises, why hasn't there been a crash between Pluto and Neptune? The answer lies in the pull of gravity from other planets. Astronomers began studying Pluto's path soon after discovering it, and its route puzzled them. Unlike most planets that stick close to the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep angle and oval-shaped orbit. The mystery deepened when they realized Pluto's path crossed Neptune's. Despite these complexities, Pluto's orbit remains stable, showcasing the intricate mechanics of space. Understanding how three celestial bodies move and interact gravitationally, like Pluto, Neptune, and the Sun, is a big challenge. It's like trying to predict where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its path, Neptune's path, and the Sun's pull all work together. Terms like azimuthal libration, latitude libration, and the VZK oscillation helps scientists solve this cosmic puzzle. Azimuthal libration is crucial for keeping planets in their orbits. When Pluto crosses Neptune's path, it's at least 90 degrees away, keeping them from crashing. Latitude libration ensures that when Pluto nears Neptune or other big planets, it's well above their path, reducing the chance of a collision. The VZK oscillation, named after scientists von Zippel, Kai, and LV, explains why Pluto's orbit seems strange but stays steady over time. Despite the chaos in space, some patterns and rules keep things in order. These rules keep Pluto's orbit stable, preventing crashes with Neptune or changes in its path. The idea of orbital chaos, showing how a celestial body's path is very sensitive to where it starts, is well illustrated by Pluto. Even small changes in its position or speed can mess up its orbit over a long time. Scientists use computer simulations to figure out how Pluto moves in space. These simulations use complex math to copy how Pluto interacts with other space objects like Neptune. By tweaking these simulations just a bit, astronomers can see how tiny changes can alter Pluto's path. In the late 1980s, these simulations found something interesting about Pluto's orbit. Even though there are factors that should make it stable, Pluto's orbit can still be unpredictable. Just a tiny difference in where Pluto starts or how fast it's going can make big changes over many years. But even with all this chaos, Pluto's orbit stays stable for a super long time, like billions of years. This suggests that even though Pluto looks all over the place, its journey around the Sun follows some sort of order. Predicting what will happen with planets like Pluto, which have wonky orbits, is hard. These systems are so unpredictable that it's tough to guess what will happen in the long run. Simulations help us get an idea of what might happen, but they also show us that we can't predict everything perfectly. These models need exact starting points, and they simulate complicated dynamics. Even a tiny mistake can lead to totally different results, which makes it hard to make accurate predictions. Understanding Pluto's orbit is important, especially when we think about whether it might crash into Neptune in the future. This knowledge helps us understand better how our solar system works. Pluto's orbit shows us how orbits that seem wobbly can balance out because of gravity and how things move in space. It's important to keep watching and studying these things so we can understand where we fit in the universe. When we explore space, we find out that things can be unpredictable, and Pluto's orbit is a great example of that unpredictability. Pluto's orbit is not like those of the other planets. It's more oval-shaped, which means it's not a perfect circle. Sometimes it even gets closer to the Sun than Neptune does. This can make things tricky because Neptune is also out there cruising along its path. There's a small chance that Pluto and Neptune could bump into each other at some point. Despite its odd orbit, Pluto manages to keep its distance from Neptune most of the time. This is because of something called gravitational forces. Gravity is like an invisible force that pulls things toward each other. So even though Pluto and Neptune might seem like they're on a crash course, their orbits are carefully choreographed dances guided by the pull of gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first glance can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the intricate mechanics of our solar system. This ongoing observation and analysis are essential for expanding our knowledge of the universe and our place within it. Imagine if Pluto and Neptune did collide. It would be a cosmic event sending shock waves through our understanding of the solar system. While we've made progress in understanding space, Pluto's situation shows that we still have a lot to learn. Studying how big planets affect Pluto's path gives us important clues about how our whole solar system works. It shows us that where each planet is and how it moves can change the paths of other things in space. Even though space is complicated, some top scientists are worried that Pluto might crash into Neptune. This makes them wonder why this might happen, even though it seems unlikely. Neil deGrasse Tyson, a famous space scientist, has some interesting ideas about Pluto. He thinks that reclassifying Pluto as a dwarf planet, not a big one like Earth, is a step forward. He believes we're always learning new things about how things move in space. Tyson sees Pluto's weird path as a sign that there's still a lot we don't know. He thinks that the mysteries of space are what makes studying it so exciting. He also knows that big events in space, like Pluto's reclassification, get people interested in astronomy. Tyson wants to help people understand the cool and sometimes weird things about how space works. He thinks it's important to talk about how space mechanics can surprise us. Tyson works with other scientists to warn people about the possible dangers of Pluto's strange path. After studying Pluto a lot, he's worried that it might crash into Neptune one day. He says this could cause big problems for our whole solar system. A crash between Pluto and Neptune would be a rare and serious event. It would release a lot of energy and could break apart Pluto. Pieces from the crash could fly around space and hit other planets and moons. Neptune might also feel the impact and change how it moves. Renowned theoretical physicist Michio Kaku believes that if Pluto and Neptune collide, it would be more than just a spectacle. It could disrupt the delicate balance of the outer solar system, affecting not just these two planets but potentially triggering a cascade of changes that could reverberate across the solar system. Kaku highlights the unpredictable nature of such a collision. While space is vast, the gravitational forces at play are powerful. The collision could create a ripple effect, altering the orbits of other celestial bodies in ways that we cannot fully predict. For Kaku, this potential collision underscores the importance of monitoring our cosmic neighborhood. Understanding the forces and interactions in our solar system is crucial for predicting and mitigating potential threats. He believes the continued exploration and observation are key to ensuring the long-term safety and stability of our planet and our place in the solar system. Both Tyson and Kaku emphasize that while the probability of a Pluto-Neptune collision is low, it is not zero. This means that we cannot afford to be complacent. The possibility, however remote, of such a catastrophic event should motivate us to deepen our understanding of the dynamics of our solar system. As we gaze into the cosmos, the story of Pluto serves as a reminder of the ever-present mysteries that await us. The more we learn, the more we realize how much there is still to discover. And in this pursuit of knowledge, every discovery brings us one step closer to understanding the grand tapestry of the universe in which we live. To fully grasp the significance of Pluto's orbit and its interactions with Neptune, it is important to consider the historical context of planetary science. When Pluto was first discovered by Clyde Tombaugh in 1930, it was thought to be a large planet. However, as observational technology improved, the true nature of Pluto as a small, distant body became clearer. The discovery of similar objects in the outer reaches of the solar system, particularly in the Kuiper Belt, led to a redefinition of what constitutes a planet. This redefinition, formalized by the International Astronomical Union, IAU, in 2006, demoted Pluto to the status of a dwarf planet, a decision that sparked debate within the scientific community and beyond. The Kuiper Belt, a region of space extending beyond Neptune, is populated with numerous small icy bodies, many of which are similar in size and composition to Pluto. This region is believed to be a remnant of the early solar system, preserving clues about its formation and evolution. Pluto's orbit is not only a result of its unique characteristics, but also reflects the complex gravitational interactions within this distant region. Understanding Pluto and its fellow Kuiper Belt objects can provide valuable insights into the conditions that prevailed during the solar system's infancy. Another intriguing aspect of Pluto's orbit is its influence on our understanding of celestial mechanics. The study of Pluto's orbit has revealed the importance of gravitational perturbations and how they can affect the trajectories of other bodies. These perturbations are particularly relevant in the context of multi-body interactions, where the gravitational influence of multiple objects can lead to complex orbital behaviors. The study of such systems helps scientists develop more accurate models for predicting the movements of celestial bodies and understanding the forces that shape their orbits. The potential for future missions to Pluto also adds a layer of excitement to the study of this distant world. NASA's New Horizons mission, which flew by Pluto in 2015, provided unprecedented images and data about Pluto's surface, atmosphere, and moons. The mission revealed a diverse and geologically active world with a variety of surface features, including vast plains, towering mountains, and frozen ice volcanoes. These findings have reshaped our understanding of Pluto and demonstrated that it is a dynamic and complex world. Future missions to the outer solar system could further enhance our knowledge of Pluto and its interactions with Neptune. Advances in space exploration technology, such as more powerful telescopes and spacecraft, could enable scientists to observe and study these distant regions with greater detail. Such missions could provide crucial information about the composition, structure, and behavior of Kuiper Belt objects, as well as their interactions with other celestial bodies. In addition to scientific exploration, Pluto's study has philosophical implications for humanity's place in the universe. The reclassification of Pluto and the ongoing investigation of its orbit highlight the dynamic nature of scientific knowledge. Discoveries often lead to new questions and challenges our understanding of the cosmos. As we continue to explore and study distant worlds, we are reminded of the vastness and complexity of the universe and our quest to unravel its mysteries. Public interest in Pluto and similar objects also plays a significant role in advancing space science. The fascination with Pluto's status, its unique orbit, and the potential for cosmic collisions captures the imagination of people around the world. This public engagement helps drive funding and support for space missions and scientific research. By inspiring curiosity and wonder, Pluto serves as a gateway to broader discussions about space exploration, planetary science, and the nature of our solar system. As we look to the future, the ongoing study of Pluto and its interactions with Neptune will continue to provide valuable insights into the workings of our solar system. The dynamic interplay between these distant worlds reminds us of the complexity and interconnectedness of celestial bodies. Each new discovery adds to our understanding of the universe and challenges us to think more deeply about our place within it. The journey of exploration and discovery is far from over, and the story of Pluto is just one chapter in the grand narrative of space science.